Good morning, students. Today we are going to discuss the structure of anatropous ovule. In last year we have studied the structure of flower, and in flower we have studied carpel, which consists of stigma, style and ovary. In ovary, there is presence of ovules. Now, what is ovule? Ovule is an egg-containing body. Ovule is an egg-containing body, or it is also termed as an integumented megasporangium. So, ovule is an egg-containing body or an integumented megasporangium. In angiosperms, there is presence of various types of ovules, such as orthotropous, amphitropous, compilotropous, hemitropous, then cercinotropous and anatropous. Okay. There are various types of ovules, but out of these ovules, anatropous ovule is the most common type. It is the most common type of ovule in angiosperms. So we have to study the structure of anatropous ovule. The structure of anatropous ovule can be studied by its Vs. It is the Vs of anatropous ovule. If we see any ovule, then it consists of two parts. First part is the funicle and second part is the body. It consists of two parts, that is funicle and body. So this ovule is present in ovule and it is attached to the point, and this point is termed as placenta. It is termed as placenta. Okay. Now the first part is the funicle, or it is also termed as funiculus. It is the stalk of the ovule. It is the stalk of the ovule. Then this major part is termed as the body. This part is termed as the body. Okay. In anatropous ovule, the body of an ovule is inverted. It is inverted. And the micropyle of the ovule, lies adjacent to the funicle. Okay. Now, this body shows various parts, such as here chalaza, then nucellus, then integuments, embryo sac, then micropyle, then here hilum, and here is the raphe. Okay. It also shows the presence of vascular tissue. It is the conducting tissue. Now, the major part of ovule is the nucellus. This nucellus shows presence of diploid parenchymatous tissue. The nucellus is covered by two protective coverings which are termed as integuments, that is outer integument and inner integument. That is, it shows two integuments, and hence such ovule is termed as bitegmic ovule. It is termed as bitegmic ovule. Then the next part is the chalaza. Chalaza is the part, basal part of the body from where integuments arise. Now these integuments covers the nucellus except at the tip, which shows presence of small openings, which is termed as micropyle. It is termed as micropyle. At maturity, this nucellus produces female gametophyte or embryo sac. It is also termed as female gametophyte. Nucellus produces embryo sac or female gametophyte. This embryo sac is 7-celled and 8 nucleated. Embryo sac is 7-celled and 8 nucleated. It consists of 3 major parts, 3 structures. These 3 cells present towards chalazal end are termed as antipodals. Then the central cell, central diploid cell, is termed as secondary nucleus, or it is also termed as a definitive nucleus, secondary nucleus or definitive nucleus. And here is there is presence of egg apparatus. This egg apparatus consists of central egg cell and 2 lateral synergies. Okay. It is the structure of anatropous ovule. This anatropous ovule is an inverted ovule in which funicle and micropyle lies at the same horizontal line. This consists of 2 parts, that is funicle and body. Funicle is the stalk of the ovule. Body is the major oval part. Body and funicle are attached at a point which is termed as hilum. This funicle and body attaches with the help of hilum, and during joining there is formation of a ridge-like structure which is termed as a raphe. Now this body consists of central major part termed as nucellus. This nucellus is formed from diploid parenchymatous tissue. At maturity, produces female gametophyte or embryo sac. Then the part of the body from where integuments arises is termed as chalaza. It is the basal part of the ovule. Then these integuments covers nucellus incompletely, leaving a small space or gap at its tip, which is termed as micropyle. Then embryo sac. Embryo sac is 7-celled and 8-nucleated. It consists of 3 structures. 3 cells present toward chalazal end are termed as antipodals. Central diploid cell is termed as secondary nucleus or definitive nucleus, and 3 cells present towards micropylar end are termed as egg apparatus, which consists of central large egg or female gamete and 2 lateral synergids. Now the functions of these parts. Now this funicle or funiculus, it acts as the stalk of the ovule and it provides nourishment to the body of the ovule from the placenta. Okay. It also raises the body. It gives support and provides nourishment to the ovule. Then this chalaza produces integuments. Then function of nucellus, at maturity it produces female gametophyte or embryo sac. Then this micropyle provides passage or way for the entry of pollen tube during fertilization. Then function of various structures of embryo sac or female gametophyte. These antipodals may get disintegrate after fertilization. The secondary nucleus and egg takes part in fertilization. Okay, this egg fuses with one of the male gamete. It fuses with one of the male gamete to form diploid zygote. Then these synergids helps in process of fertilization. That is, during fertilization, one of the synergid form a structure which is termed as filiform apparatus, which helps in attracting pollen tube. Then the secondary nucleus fuses with another male gamete to form triploid primary endosperm nucleus, which later on produces an endosperm of the seed. Okay, so this is the structure of anatropous ovule. And now we have to study how this female gametophyte or embryo sac develops in angiosperms. That is the development of female gametophyte in angiosperms. Development of female gametophyte. Now, in angiosperms, the female gametophyte develops inside the ovule, that is inside the nucellus. The development of female gametophyte in angiosperms is mostly monosporic and endosporic. That is, it develops from single spore, that is megaspore, and it is completed in within the spore and hence termed as endosporic. Now, suppose it is nucellus. In nucellus there is presence of diploid parenchymatous tissue. From this tissue, one of the cell of nucellus, which is hypodermal cell. This one of the cells of nucellus get activated, enlarged, and it acts as megaspore mother cell. It acts as megaspore mother cell. This megaspore mother cell undergoes meiosis. It undergoes meiosis and it forms 4 megaspores. 4 megaspores. Okay. This process is the formation of megaspores from megaspore mother cell by the process of meiosis is termed as megasporogenesis. It is termed as megasporogenesis. Now we have to study again detail from megaspore mother cell. Suppose it is megaspore mother cell. Megaspore mother cell. This megaspore mother cell divides by meiosis to form linear tetrad of megaspores like this. Linear tetrad of megaspores. Now, all these megaspores are not functional. Okay. Upper 3 megaspores, that is the megaspores present towards microbile. Towards microbile. Or microbial megaspores are non-functional. They get disintegrate, and this lowermost chalazal megaspore remains as functional megaspore. Okay, it is important. Okay, which megaspore is functional? Chalazal megaspore acts as functional megaspore. Now, this functional megaspore enlarges and develops female gametophyte. Suppose it is functional megaspore. Now what happens? The nucleus of functional megaspore divides by mitosis. That is the first mitosis. Nucleus divides by free nuclear division, mitotic division, to form 2 nuclei. There is 1 nucleus at each pole. Again, these 2 nuclei divides by mitosis. It is the second mitosis. By mitosis, again it forms 2 nuclei. Here 2 nuclei. Here 2 nuclei. Okay. First mitosis, second mitosis, then third mitosis. By third mitosis, it forms 4 nuclei at each pole. 4 nuclei at each pole. Okay. Megaspore mother cell divides by meiosis to form 4 haploid megaspores, which are present in linearly, which is termed as a linear tetrad megaspores. Out of these 4 megaspores, 3 micropylar megaspores are non-functional. They get disintegrate. Lowermost or terrestrial megaspore acts as functional megaspore. This functional megaspore enlarges. This functional megaspore acts as first cell of female gametophyte. Now this nucleus of functional megaspore divides by 3 successive mitotic divisions to form 8 nuclei, 4 at each pole. Now what happens? There is a rearrangement of these nuclei. One nucleus from each pole migrates into the center like this. Then 3 cells remains towards chalazal end and 3 remains towards micropylar end. These 2 nuclei are now termed as polar nuclei. Okay. It is termed as polar nuclei, antipodals and egg apparatus. And final structure of female gametophyte is like this. Here secondary nucleus, antipodals and egg apparatus. Here antipodals, then secondary nucleus. Here is the egg and these are the synergies. Okay, such structure, this structure is 7-celled and 8 nucleated structure with antipodals towards chalazal end, secondary nucleus in the center and egg apparatus towards micropylar end is termed as fully developed female gametophyte in angiosperms. If we start with megaspore mother cell, then for formation of one female gametophyte, it requires 1 meiosis and 3 mitotic divisions. Similarly, for formation of single egg, it involves 1 meiosis and 3 mitotic divisions if we start from megaspore mother cell. So, we conclude. We have studied the structure of anatropous ovule and development of female gametophyte.